Hello, everybody. We are going to start in a few moments from now. Thank you. Okay. Hello, everybody. Hello, SolidCAM community. Welcome to this SolidCAM webinar series, where we are going to talk only about post-processors. And we generate this webinar series based on your request. And here, mostly, we are going to talk about all new features available in SolidCAM 2021, how to use them inside the post-processors. But also we are going to show you what are the things necessary to know about when you want to convert the existing post that is built in earlier version, and if you want to use it in the latest SolidCAM 2021. Before I started, I would like to say a few things about the forum. So I'm going to jump into the forum. And you can visit our forum on the forum.solidcam.com. And I already sent to most of you an email about what are the subjects that will be covered in this post-processor training course. And but if you are not aware of this, you can go to the forum and you'll reach the post-processor topic. And over here, you will find out the new subject that I just created yesterday. And over here, you will find all the subjects that we are going to show you in this webinar series. As you can see over here, we are planning to make 5 of them, okay? But this time we'll also try to make it a bit different. We'll try to involve you as our partners, as our customers, as our colleagues, to participate it in the way that you aren't going to write it here, the subject that you would like to pass, to be passed in this webinar. So there are potentially also that there will be 6 or maybe even 7 webinars. So this depends upon your request. So please log into the forum and just write it as down here, as everybody will be able to see that as well. This webinar series will not be only given by me, but also by the whole international support team located here in Serbia. So enjoy. Right, so I hope that everybody could see it. Yeah, I can see that everything is okay. All right, so what you have in front of you, I have opened one project. Maybe you are already familiar if you watch some of my earlier webinar. So I open here in front of you, the SolidCAM 2019, and over here, yes, as you can see here, and the project that it's open here is the NTX 2000, okay, and it is the one that has the main spindle, sub-spindle, upper and lower turret. And this is my existing project that I have done also earlier, and I wanted to convert this and to make sure that our customer can use this post in the latest version. Okay, so what are the steps that I'm going to make it? I'm just going to show you. I wanted to do something here actually before I continue. I'm going to take the print screen off of this window, as I will need it also later. Right, so the first thing, I will go to my VMID. Inside the VMID, as we are building the SolidCAM Toolkit 2021 for I think 4 years, we already knew it, what are the things that will need to be updated inside the post. So we, from version to version, we intentionally put something inside the VMID even before 2021. And the one of the main things that you are going to see, and that it's extremely important in the 21, is a folder of the tool magazines. And if the post was built even in 2016 and you save it, for example, then in 17, 18, 19, eventually you will see here that that the tool magazine folder has been built. Now, depends from the kinematic to the kinematic. The tool magazine will also have a turret attached to this folder, okay? Now, this is extremely important. I will not do in this case, so I will intentionally not put any kind of turret over here, and I will save it and open it in 2021. All right, so I'm going to send a project and save it, including the machine simulation. And I'm going to put it just one level before here in the project. Done. And I'm going to extract it in the folder that I'm going to use as well here. So I'm just override this, and I'm going to use this path as my project of the post, including the machine simulation as well. For these, I'm using the SolidCAM settings to easily, jump from one version to another version. So if you don't have this one, and you are interested to, just please write this down, in the forum. So I'm going to use the SolidCAM 2021, and as I'm pretty oftenly changing the versions, I need this kit for sure. Okay, so I just left before it started, so I'm going to do it again. Started. Okay, so as it is loading, I want to give you a few things to mention here before it opened. So first of all, the VMID itself, it's still in version 2019, and I'm intentionally will open it in 2021. Now, the first question that it's coming from most of the people, like, what will happen now with my new VMID? Would it be automatically converted? Quick answer, it's no, it will not be automatically converted. But what will happen is that SolidCAM will, in this version, will make something that we call it like temporary VMID, okay? So behind the scenes, it is still 2019, but we kind of open it in temporary 2021 view, okay? So what you could see now, as this is coming like very often into support as well, is that you are trying to open the project that didn't have, the magazine defined, and this is how it will look like. So then people will, get scared, and you are going to hover with the mouse, and it says like the tool is not from the submachine turret. Okay, so let's go to the toolkit. Here it is how it looks like. On the first side, it seems that everything is fine. There are all the tools there. Everything is fine. I will even go to my machine preview. I can see all my tools are here. My one tool is there, but the main difference is that as we don't have the magazine, we only have one tool assigned on my upper turret, while all other tools are stored in the storage. Okay, so you need to understand the storage. It's just like a folder where you can throw up all your tools, but they can't be used in your project up until you don't assign them into particular turret, if it's the linear or a revolver. But if it's in the case it is the spindle type, then you need to put it into a magazine. Okay, so this is the first problem that you will face it off. So how to get fixed that? So the easiest way is to edit and to modify the post before you really open it in 2021. So what I'm going to show you now, it's one very nice feature that most of you don't know about it. As I already convert my project into 2021, I would like to not save it. So just do right click over here, and I will go close without save. And then I will be also asked again if I'm sure about it. Yes, I'm sure about it. Right, so let's go to the folder. And what I'm going to do, I'm going to open it. It is over here. I'm going to open it in SolidCAM 2019, and shortly I will explain you also why. So I will go over here, and as you can see, I already have here tool magazines. Also, what is also pretty important for later on to pay attention to the axis patterns that we have defined here. Also, pay attention about the view on the controller definition as much as you can, and also on the working style, as there are some parameters over here that will be moved also as well. And I'm going to talk about that in today's webinar, so it's kind of important as well. Okay, so I will just, the way to do it properly, you just do a right click on the folder and just add tools magazine. And what will happen is that we'll have here the magazine, and we have also the number of the pockets that can be there. And we have the turret here that is defined as he automatically inserted because it is spindle. In order to add more, of course, in this project, it will not have sense, but you can do a right click and add turret. Now I will save and exit. I'm still in 2019, and now I can go back into my project and I can reopen my pod. Okay, you note that I did everything in 2019. And the reason why I did that, because now, as you can see, there's no missing tools there, okay? Everything is fine. I can, before I recalculate the things, I can go to the toolkit, and you can note it is now a bit different. So now all my turret on the lower, it's also assigned, but I also don't have any kind of storage. So therefore, all of my tools are properly assigned to my upper turret, you know, over here, and now I'm allowed to use them. Okay, this was like coming a lot of questions about it, so pay attention before you do such a thing, you know, to just make sure that you have the magazine in the case you have the spindle. Of course, now as you can see, I'm just talking all the time about the mill turn and the Swiss type machines, also particularly this webinar. I'm not talking about the milling, because most likely you will have zero chance to not have this folder and the spindle included in your VMID. Okay, so for the milling, it will be pretty much straight. Okay, now 2019. Next question is coming like, okay, we realized that when I've modified, you know, what most of you did, you open it in 2021, as I'm doing it right here, and you add this magazine in SolidCAM 2021. So you intentionally add it there, and you did like a 7 exit. Now, what SolidCAM will ask you is like, hey, are you sure that you want to, you know, to save it, because you will not be able to open it in lower version? And most of you click on yes, and then you have a problem with using the post in 2019. So my advice is, if the customer wants to use the post processor in 2020 and below versions together with 2021, please make sure that all change that you need to do, you do it in earlier version, you know, for the VMID, and then everything will work then also properly in 2021. Once you save it in 2021, there's no way to open it anymore in 2019. And then what are the things and reasons for this? So when I save and exit, you know, there will be a few things that will be missing in that project, in that VMID, and it is quite reasonable. First of all, the axis pattern that I mentioned just a few moments ago, they are completely moved, you know, towards, you know, the controller definition that is located over here. The next thing is that we have added a new folder, and all our position indexes. When I say position indexes, I'm talking about these indexes. Okay, they are now located over here. Okay, and we are going to talk about them a lot in this session. And of course, we have also in the working style, we have a new folder, a toolkit. I will not pass everything, you know, in this webinar, as you know that we have 5 of them. So we are going to discuss about each one of these in depth also later on. So once this is saved, there's no way that in the VMID from 2019 will be able to read this stuff. Therefore, I will just repeat it. If you want to use the particular VMID in both versions, you know, just make sure that you perform these kind of modifications in the previous version itself. Right. Okay. Yeah, let's not leave the subject of the tool magazine. There is one new get function available with the magazines, and this is particularly important mostly for the Siemens controllers. Of course, for any controllers that have more than one magazine, okay, because it's important how you're going to call your tool. If you have like two magazines, you can have the same tool number in both of these magazines. And the only way to distinguish which magazine you want to take the tool is that you know which is the magazine that you're taking it. So we create like a get function in order to distinguish from which magazine this has been called. Okay, so for doing that, as you can see now, I'm pretty fine to save it, so I'm going to save it. And once you did that, SolidCAM will move all the temporary VMID of 2021 into a new VMID. So what I have to do is just to reopen it. Okay, few informations. You can go up to our help file, and I just want to use this opportunity to tell you that this file is always updated. And for this get function, we have moved completely our get functions into a folder view. Okay, so if you need anything, you can basically find them here. Of course, you can use the search button as well. And we realized that we are missing like 4 or 5 get functions, but don't worry, within the next versions we are going to implement these as well. And over here you have getting the magazine ID, where we at least tried to have very good example, how this can be used. So in most of the cases, I will just I'll just copy these these things here. Can I do that? I should be able to do it. For some reasons I can't do it now. Is everything okay here? Let me try again. Maybe something is happening after after I reboot my system and after the update. So I'm going to try it again. I simply cannot do it. Okay, so also my Windows key doesn't work. Okay, that's interesting. Anyway, so let's try it manually. So I'm going to open my post from the VMID. There you go. And the proper position where I'm going to put this is just like start of job. I can put it there. I can put it also in user start of job. I know that you are guys not familiar with this post, and for this opportunity you don't have to be at all. But I'm just going to use and just scroll it down. Let's say up to here, and I'll try to. Yeah, it's really working weird to just write it manually. So I will have to do everything manually. So I will just do the local and integer. Integer, and I will use the standardization for doing this, and then I'm going to assign this to my new get function. And the get function is just simply write get magazine ID, and then you just put here the tool tag. Now, if you are not familiar with the tool tag can't be used really in like G code itself. The tool tag is just a random number that is generated, and it I like to say like detects what is the particular tool that you select. Okay, it's only valuable if you are using them into get functions. Okay, and we are going to use that a lot here. And to check what is the magazine ID, I'm going simply to just output into kind of single block, where I'm going to say for example, like tool, and then I'm going to close this, and then I'm going to put here tool number, for instance, is in the magazine with ID, and then ID like this, close, and the magazine ID will be this. And close it, maybe close the parentheses here, close the brackets, and save it. Right. Let's go back to project. It's interesting. I can't back to project. That's weird. Okay, there you go. All right, so I'm going to use my tool number 1, and it is from my upper turret, and I'm going to generate the G code. Okay, there you go. I have my G code for the channel 1, for channel 2. I'm going to scroll it here, and here you go. So I know that my tool 36 is in the magazine with ID 1. Okay, now a little bit interesting fact here. What is happening with all tools that is on the lower turret? So what if I use this get function for the turret that's on the lower turret? Okay, so let's see what is happening there. So what I'm going to do, I'm going to take this job, but just use, my lower turret for it. Let me find the proper tool. And the tool, I can also go with my advanced view maybe. I'm going to open my tool viewer and let me find the appropriate tool for this. This is for the face. Here's the one for the radial, but this is staffing. Here we go. I'll use the tool number 9. Right. I'll just save and calculate. I'm pretty fine with this. And I'm just going to generate the G code. Now, most of you will just say like, hey, if I'm using this function, I would expect that I will return, like an error. But actually, this is not going to happen. You actually have the ID, it's 0. So to understand this better, even if there is no magazine for the lower turrets, which is in this case, revolver. So if you have like a revolver or linear turret, they will be moved in, let's call it now, kind of temporary magazine. So in the background, it's still magazine, but with ID of 0. I think this is kind of important. It will be also very much important in the close future that we are going to discuss about that also. Let me leave something for the surprise. Okay, so the question is, just let me give you one example why we need this. For instance, you could have, let me go with the red maybe. You could have a situation where you can have, this is very particular for the Siemens, they have like a cycle for it, where they basically need to mention from which magazine it is taken from. But I can say like it's 136, for instance, where the first indicates from which magazine this has been taken from. Okay, so this is just like a silly example where this particular magazine ID get functions can be used. Right. Perfect. Next things. It came to support very often that, especially for the Milton projects and also Swiss type, is that everything, the conversion was done smoothly, everything is nice, but then after generation of the G code and comparing it with the project in the earlier version, there is indication that the plane was actually different. Okay, so for some reason the plane, the one that was like G17, now it's G19 for some strange reason. After investigating, we realized that the get tool direction in station is getting us a wrong value. Now, for all of you who never heard about get tool direction in station, let me just give you a short background story. I'm going to search for it. So get tool direction in station, here it is. Now, just a background story. This is what most of our post-processors include, this particular procedure, and then later we're actually checking if this tool is actually mounted along the Z direction or not. And based on this, we actually generated the planes. And it was an issue in the previous versions. As for the turrets that didn't have the Y-axis, we were unable to generate the correct plane. So today, that's not at that time. We basically generated the get function, which allows us to get the direction of the tool. So basically like this. So let me just make a pretty quick drawing. So this is my revolver, okay? And what I'm going to do, I'm just going to make this also radial tool here. And just, here it is. So each of, I will just make it with green. So each tool has the direction of vector of the tool that goes from the tooltip towards the tool, okay? Now, over here, the turret has the coordinate system, and let's assume that this is the lower turret. So in this case, this will be the coordinate system of the turret. Here we go. Okay, so this is it. So we have here the station, which also has this coordinate system. So let me just draw it a little bit better. Here you go, and we have it also over there. So this function basically indicated, is this like going, give you the angle, between this vector, and the coordinate system of this station itself, okay? Now we are coming to an issue in 2021, as let me go back first to the print screen that I took, before. You probably remember that I took this. So in earlier versions, we were not able for the linear turrets to change. Let me go here. You're not able to reorient your tool along the y-axis. So you couldn't rotate it, around the y-axis, but only in z and x. So therefore, the function, when it was made back then, was able just to support, this particular case. But because we had, a huge library, with this get function, we say that we are going to convert it for the all posts that are using it in this way. So we assume that along the y-axis, nobody use, it along the y-axis. So the conversion was done like that, but there are one tricky thing there. If you have this kind of condition where you say, that my second, which is like rotated along the y-axis, it's equal to 90. So pay attention, plus or minus, because here we take the absolute. The tool, it's mounted along the z direction, and therefore the G-code plane was like printing out the 17. But there is a missing thing here. If you define your stations, this default tool direction is taking a big role in this conversion. So if you have, by any sense, let me see, this is the tool number 9. I hope I'm also using the tool number 9 here, the station. I'm going to click on 9, and intentionally, I will just put, the default tool direction to be along the Z. I'm going to save it. And as this tool is like approaching radially, so we are expecting, to get on the G19 plane. And for this, I'm just going to generate a G-code. Here's my G-code, but the output that you have here, it's G17. So let me change so you can see it maybe a little bit better. So now it's G17. Hey, we have a problem. So all the posts that were using this specific get function, and they were analyzing this with this if condition, they had a problem with the plane itself. Okay, of course later with the drilling cycles and everything. Okay, but this is the core of the issue, and it's only because you put it there. So you have two solutions. The first solution, either you will change and modify the VMID, and you will change default tool direction over here like this, or you will leave the VMID and then modify the if condition over here. So you are going to check what is the output in that case. So in that case, you will need to put here a 0, and then that will be the solution. Okay, so I hope that makes sense to you. So you don't have to change too much. As you can see, it's pretty fine. So now once I use along the X and I generate the G code, you will note that now my plane is correctly defined. Right. With that being said, let me go to another problem that is basically connected to this one. We have some machine that requires, the input into a controller, into a G code, how the tool is actually oriented. So you could still use, the get tool direction in station, but even though you need to understand that here, this is actually not a vector. Okay, so I'm going to change this from vector to angle. Okay, so I'm going to change these and this. So this is an angle. But what if you want to get a real vector? So in that case, I'll just get tool direction, get tool vector direction in station. There's a new get function that will allow you to do this. Okay. Of course, then the conditions would be, of course, different. So in that case, the only difference that you need to do, I'll just use get tool, and then you have here vector direction in station. The input of these get functions, it's exactly the same. But in this case, you could use not the angle x, sorry, not the angle, but really the vector. Okay, so I'm going to change it, completely here. There you go. And this is also a vector. There you go. So now this function will allow me to make it, to receive the output based on the vector itself. So what I will do here, I'll just copy this. I will not call this function. I will make a call of this function. Of course, now the tool direction will not be, now it works completely different. I will not draw again this image, but the vector is the same. The output can come from -1, 0 to 1, and any other angle, or sorry, not angle, but vector in between. So in that case, the output will be different. So if you would like to use this particular function for this one, so I will suggest you to not use the y-axis, but in the case if it's like the x and it is, sorry, it is z, okay, and if it's 1, an absolute, okay, so if the third component is 1, then the tool is mounted along the z direction, and therefore the plane 17 will be generated. I hope this has a lot of sense to you. Let's go to the next subject. Let me see. Yes. All right. The next subject is, I will go to my VMID and I will talk about the index tables. And the best example, there's no better example than showing the index table on the integrex of the MASAC. But let me show you what this is all about. So now, instead of having, each of the station to have like maximum positional letter, now here we have a new parameter, default index table, where you can select the index table that you want to have, which allows you to create more index tables, okay, and assign them to different stations. So not only different stations, but also you can have more turrets, and then apply different index table to that particular stations. Okay, so let me give you an example of getting the MASAC tool offset in that case. Okay, tool indexes. I have prepared something here, and let me go to the programming manual of the MASAC, and I'm going to jump into tool functions. I don't want to set it as default. And here we have this page. So for all of you that are familiar with this, great. For all of you who are not, here you can note that the ID code for this, it starts from A, B, C, D, A, F, G, H, and then I, it's missing. So and there is a lot of them that are missing. Okay, so let me show you how you can today actually how this can be actually supported. So I go over here, I go to my index table, okay, and I'm just going to continue. Of course, I will have the ID, okay. So in the past we had kind of ID, but now you also have a letter. F, G, H. And now we are approaching to I. So I don't have to do it like this, but I can say not available, okay. K, L, and I will not go, completely there. But we had in the support one extreme, as it was like this. Okay, I misspelled it here. All right. Now there is one tricky thing that you need all of you to know about the index. This is a string, but only 9 characters you can use inside. So if one of them it's kind of not available and you want to skip it, use something that is less than 9 characters. If you have more than 9 characters, you will have difficulties and issues inside the toolkit. Okay. So I will just delete this particular one. So I just want to have, for example, this one. For example, this one, like this. Now, yeah, good and tricky part. Now, because I have 2 times and like not available, the way how you can trick it is like to put the space between. So it's invisible one, but still it looks pretty nice. Now, what I will do here in this case, I'm just going to take, of course, it will not automatically put your maximum position letter here, okay, as you can see here, but you'll need to choose that. So for let's say for my tool number 9, I'm going to take up to L, 7 exit. You don't need to reopen the project, okay? And I'm going to take my lower turret tool number 9. I'm going to take my quick here, and here I have my tool offset indexes. I can go there, and this now for the Mazda customers, this looks a way more beautiful, than in the past, as this was quite limited, for example, to 2 or 3 or 4, and it has great impact on the machine simulation. Not anymore. Okay, so you can define as many you want. It will not have. We don't need to generate so many substations in machine simulation. This is something that we are going to discuss in the future webinars. Okay, so let's take an example here. I just save it. I want to use it, and let me go back here for a moment. I'm going to take a 9, and let me change the index to something like C. Right. I will define this in my trace, as I want to show you a new variable that we have. The new variable, you can find it in change tool and also all the related like def tool, offset and stuff. And let me just go to my language and GPP black so you can see it. All the kind of blue one, it's something that was available in previous versions. Everything that is kind of white, it's the new variables, okay, available 2021. And in this particular case, as I'm seeing in some post, the tool position here, it's set to C. So you as a developer of the post, what you had to do, you had to check, the C, which was actually the position number 3, and then you needed to convert it into a string. Not need anymore. So basically you have the new variable called tool string index, and you have a string available over here, so you can use just straightforward. Of course, a few conditions like, what if it's an, if in string it is and not available, you can give an error message to our customer. Super one. Okay. Let's jump to a few things about the MCO. I'm super excited about the MCO. The first thing that I want to show you, it's a little bit small update in SP3, as we do have in our options here for a table. So pay attention that I'm in a table. So we have a new option of coolant flood through a table. So now we are able to define a flood to any of our table devices. So I will just go on and off, and now I will be able to create a new MCO. And the MCO, I'm going to take my main spindle, and over here you have an, where it is. Yeah, here it is. So you have the flood coolant. You'll just turn it on. Let's go to the trace quickly. And it is on my second channel, so I'll go like start machine control, and here we have like flood table, and we have here the variable that you can use to output any of your M code for your particular device number that you have over here. The device type, when it's 1, this means a table. Okay. Right. Next feature, also pretty nice one, is it is a feature that you can see in any of your, let's say, prepared MCO functions, MCO cycles. In this case, I have prepared here a lot of MCO here where we are pulling this part from the main spindle. So we have the cutoff procedure here. And I have here one MCO with the parameters here. Now, the way how we are doing the part transfer, let me show you here, is that we have the rapid preposition. So we are going to preposition the sub spindle in front of this into absolute machine A-axis value. And then we have safety feed distance. And then I have the setup location. Now, every of these attributes, I'm calling it, they are the system one, and they are calculated automatically based on your CAM part and your setup locations. Sorry, not setup location, but machine setup. So we have here setup location, and once you did that, now you are able to see what that value is. This is very handy, very important, not only in the part transfer, but let me give you another. So here we have, for instance, like lower tower the retract position, and I here have, you know, parking position, which is 800, but I have two new one. It's also not new one. In some version of 2020, we add this minimum and maximum limit. So, but now if you click on the minimum limit, you can get what is actually the minimum one. Okay. So this is very, very nice, especially in the Swiss type. When you clamp the part, you can exactly see the part coordinates are located in the bracket. So you can easily see if this clamp position is the correct clamp position that you are expecting from the setup that you have defined. Right. Now, the second thing that I want to show you here is ability to put the formula into these fields. So as you can see, when I edit it, it's still the attribute, okay? And when I deselect it, is the value. But what I can do, it's simply to write the value in this cell. So I can just go here and say plus 100, and what will happen? The SolidCAM will automatically calculate this. That's so good. I like it. This is very nice option. You have it like this, but you can also do it like this. So you have the min limit. So you can go to this cell editor. So this is also supported in cell editor. Okay. Just okay. A few things. What are the question? What are the operators that you can use? So it's just plus, minus, multiply, and divide. Okay, these are four for now, and we probably will put more, and we are going into a direction of putting more attributes here. Okay, but stay tuned. You know, you will be informed of that as well. So you can click OK. The new value will be calculated. You can click OK, and you can get new parking position. Something is wrong here. Let me reload the tools. Here we go. Great. A next feature that I want to show you with the MCOs. Let me go again to my catch part. And I used to, when I'm doing the pull, I will not use this one, but here I have the pull part. And here I have the value of my pull, okay? Now, all of you know that this was a bit difficult to do in the previous version, but I want to show you a new way to do it in 2021. I think it's the easiest way for now, and that is when using, you know, the current location. The current location is the new attribute that you will find in this drop-down menu, and it is so powerful. Even it looks like it's simple one, but I will give you a few how should I say, examples of how you can use this on a very powerful level. So the way how I used to pull the part was that this was set to my setup location, and when I have the setup location, it is there. Well, that's fine, but how I can calculate, you know, the pull part? So I think you can see where this is going. My part, it's 100. My cutoff tool, it's 3 millimeters. and my allowance on the main spindle is 0.5 millimeter. So what we have here is that we need to, pull the part for 103.5 if we want to have correct pull part location without, pulling out bar from the bar feeder. Okay. So how to do that? I used to have the setup location, and then the customer needed to go over here, go to cell editor, copy this value, go to calculator. My Windows button again doesn't work, but I can go to calculator. I go over here, I put 0.5, and I then copy this value and bring it back to the cell. So that's hard way to do, and the easiest way to do it, okay, is to go to this, for example, setup location, and then just 103.5. Here we go. You can go to the preview, my setup location, my pull position. Now you can ask me, okay, yes, Daniel, but the setup location, it's fine. We can put the value directly. How that has any things with the current location. Okay, so the reason why I'll do the current location, and I'll go to the controller definition, that's for sure, and I'll go to my pull part. I'm going to find my part move, and it's automatically set here to the setup location. So I'm going to change it to the current location, and I'm going to save it. Okay, now I'm going to go to my pull part, and then I will just select my pull part, and here I have my current location. Now, why this is better? Okay, it is better because maybe in the catch part, you will not really catch it according to your setup location, but you will catch it in different location. Okay, when it's in the different location, you can use the current location again, and you can just use the same formula. This is one way. Of course, there are other examples of, for example, lower turret retract position. We can go over here, go to the parameters. This one is only a retract position, so it will eventually go there, but I can always use my current location, and then I can say I want only go to minus 200. That's so nice. So use this current location often, guys. It's so powerful. It can give you relative movements. Okay, so like with putting relative input, and you can get relative movements in your MCOs. Right, I think I passed all that I wanted. Yeah, there's one small thing here that I forgot. Okay, so we have here the lower turret job. Okay, let me go here and open it, and it finished the jobs over here. Okay, so this is pretty much applicable for the Swiss type machines where you want to move your part inside the guide bush, for instance, or you want to, for example, pre-position your tool in respecting to your part in local coordinate system as we have it here. But unfortunately, in our links, we don't have any lead out option that I want to go. For instance, not along this Z. Okay, so let me go to this will be the same. So I don't want to go in this direction, but I want to move this in some particular direction where I will not have a problem with when using then the upper turret, for instance. But I want to do that from the part coordinate. I don't want to go from the machine 0 and use the machine values, to move it to the safety. How to do that? In the previous version of SolidCAM, when you wanted to do something like this, you had to take, the submachine, and then, take the submachine and put here the value. But the problem was that before you make the submachine movement, you really need to take your lower turret here, and then to go to the tool change, and then to select a particular tool that you want to be as a master. Now, you don't have to do it. This was a little bit like annoying because every single time when I want to do something like this, I need to select the tool. And this time, this action, it's not anymore important. You can just basically remove it, and you can just straight up use this one. So let me go to the preview. So I have my tool over here, and I want to make my movement. So for instance, I want to go to 0 here, and as you can see, the latest tool being used on my turret will be automatically selected. Of course, paying attention of the code of the submachine that is used over here. So I can go with my 0. I can say, yeah, please go 50 here, maybe in X like 50 as well, and I have my retract. There you go. I don't need to reselect the tool. Yeah, it's a small update, but I think quite awesome, that you understand that this also works great now. And the last feature that I want to show you today in this webinar, and we end it for now, it's new. Let me go here. I'll open it. I'll close this project, and I'm going to open this one. It is the feature called local coordinate, local plane. Okay, the variables, it's first, second, and third local plane. And I'll try to explain you why we actually need it, why this particular customer required it, and what I have here in front of you, it's the GROP G352. Let me go to the toolkit here and open you this machine. Here is the machine. Oh, let me go better into setup. It will be better. So this particular customer had this pyramid fixture that he wants to have the pot and the fixture on each of the side, and he wants to have a part here. But the problem with this is, if you try to do something like this in SolidCAM, where we say, Mac 1, our Mac 1 in that case is the master Mac, okay? And if you create Mac 2, Mac 3, doesn't matter how many Macs you create, all plane rotation will be respected, regarding to this Mac over here, okay? So this was not acceptable for the customer, because if you are going to handle everything by this Mac, okay, there's always a chance that the customer will not set up, the part exactly correct on the fixture, okay? So you need to have separate output for each of these parts, so G54, G55, G56, and to have local plane rotation, on these parts, okay? So let me show you how this actually looks in the G code. So I have here this, let's say, test part, where I have like a few profile jobs and drilling on each of the sides in order to test this, and I'm going to generate the G code. This is how the G code looks like. So let me go to Panakiso. So I know that most of you don't understand this. Trust me, I don't understand it either, okay? But the main thing what you should understand is this work offset list that we have here. So for this part, the customer used G54, G55, G56, and the offset that they are using on the machine, it's exactly the C value that they use there. So what is necessary, it's only to put, the C will be 0, but they need to put the B angle there, or without this, you can use the cycle itself. So then what we have for each, this is like a null point, or the G54, we have the position 2, 3, 4, 5, and 6. And then for each of the 55 and for the 56, we have also the cycle 800. For all of you who don't know what is the cycle 800, the cycle 800 is for the tilting plane rotation, where you are going to put your shifts, okay, and your rotation of this, okay. Now the greatest advantage of using this kind of system is that you can do this way only if you are applying the local plane rotation. So which means the output will not be everything from the Mac 1, but from each of the Mac that you can see here. Let me just hide this. So from each Mac available. So if I go to the coordinate system, I have only 3 Macs, allowing me easily to multiply and to send this same toolpath to all other Macs. Okay, so if I go to the transform, you can see that the transform Mac to Mac, actually it is used. Right. So what is the benefit of this? I will not go into very details, but I'll just open the post. I want you to see this mess. And the variable that you can use is it's local, first local plane, second local plane, and the third local plane. I store it here in some variables, okay? So I can later, let me just split it to right. I can go over here and I just store them in some string because I need to make some kind of manipulation at the end to print in on the very beginning and so on. But the idea is that, yes, you can use this, you know, for your each Mac, okay? It is not connected to a setup Mac, okay? I hope I didn't confuse you. Not only the plane, but also you have the local shift. So to summarize, the output of these planes will not be according to the Mac 1 position 1, the one that is selected inside the setup, but for each of the Mac you will have local plane rotations. Now, important thing and fact to say is that that particular output works only and only if the tilted plane definition is set to customize, and then you will set, you know, the Siemens rule of the rotation. But if you use any of these like kinematic axis or use cycle 19 options available here, in this case the local plane will not work. Okay, so we didn't build these variables to work with these settings over here. Okay, so if you want to use these variables, use customize, set a bit here, and you will have it calculated there. So these variables can be seen, you know, in rotator plane, also the plane data. Yeah, I hope that this webinar was interesting to you guys. I hope it was not too long. I hope you enjoyed as well. I see there is a lot of questions. Okay, I will not spend now time with answering all of these, but I will tell you like this. Please, for all the questions that you can find in the webinar, or you have like particular subject that you want to pass, please, you know, go to the forum and write us in this topic, okay? And we can make sure that each of the the threads that are here, we will really consider it well, and we are going definitely to pass it in our future webinars. All right, so I wish you pleasant rest of the day, and see you in the, in the 7 days. Thanks a lot. Bye-bye.